We're going to talk to you about how to build an entity resolution pipeline from scratch. So this is me, software engineer at Vouch for data, joined 5 months ago now, hard to believe. Before that, I worked at a couple of startups. I've worked at also very large banks, so experience working places where you can do things and experience working places where you can't. I live in California now, but before that, I was in Toronto. I have a dog, I have a cat, and that's me. I work at Vouch. We're a small business insurance startup for small businesses. So it's made by founders for founders. We're trying to make getting insurance for early stage growth companies very simple, very straightforward. If you've ever done anything insurance, you know it's probably not that. So this is our application page, and that's important to understand because you can see why maybe we'll have problems down the line. Because we make the customer experience very simple, which means we make the data experience a lot harder for people like me. You just provide these 5 things, a couple other questions after you begin, and then you're sort of good to go within minutes with your insurance for your company, which is pretty cool. Also, none of these fields are validated, so you can put anything you want in example.com or your email, which we'll get to later. So data problems. We have them. 2 things kind of happen at Vouch. One is somebody starts an application, forgets about it, comes back later. And so we have multiple applications from the same person or multiple people at a company both fill out the application and they use varying ways of spelling their names or the company names. And so we have these duplicates. Maybe only one of them leads to an actual policy, but we still want to sort of collapse this down to like understand our funnel and where are these people coming from? Did we really get 20 applications from one company, or is it just a one and they click submit 20 times? All that fun stuff. We also have third-party systems. So this is information about companies that we source. We like to know maybe, for example, how much funding did they raise? How many employees do they have? We can use that information to help them during their application process so they don't have to fill out everything. So these are the 2 systems we sort of have, our internal duplicates and our external third-party systems. They have information about companies and we kind of want to link them together somehow. But it's not always easy to link things together. In the perfect world, everybody would give me their EIN before they talk to us. That's not really going to happen because most companies don't know their EIN unless they go find it in their IRS papers. So we don't ask for that. Instead, we ask for a name, a website, and the email. And as you can see, there are many different ways of inputting that information. You could do it in lowercase, you could add a the or a co, you could do the friendly name, you could do the legal name. You could forget what your website is, that happens sometimes. You might forget that you're putting an email. You might copy paste a website from some other page and you get this weird www2 stuff. You might have something that looks like it might be the same, but it's definitely not the same, like this dialectical behavior therapy website. And so the question is, how do you link the ones that are really part of the same entity, and how do you leave the ones that are not part of it out? And I'll show you. Yeah, so all you have to do is read a book, and then everyone will think you're really smart. So that's what I did, and I just followed the instructions. There's like 5 simple steps. And if you have any questions, if you want to know more, I highly recommend this book. It tells you everything you need to know, gives you references to find out how to do things if you don't know how to do them. Everything about data matching is in here. And so there's 4.5 easy steps. This is actually the same slide photo from the template. I just thought it worked really well, so I put it in here. All you got to do is pre-process your data, which as data people we're probably very familiar with. Then you got to do something called indexing, which we don't normally do, but it's not that hard. Then we got to do something comparing, which I think is pretty natural to most of us. Then we got to do the thing called classifying, which none of us like doing. And then we have to merge it, which means making decisions, which we like even less. So I'll walk you through all that. And if you have questions, stop me. I can't really see the chat, but feel free. So what we're going to talk about is a bunch of DBT, a little bit of Python, and then some more DBT. That's sort of the workflow that I have to create these entities. So we'll start with DBT, and we'll start with preprocessing. Everyone loves preprocessing. It's very simple. You just make things more common than what they normally are. So if you have things like the DBT and DBT, maybe you remove stop words like the, you remove punctuation, you trim everything, you lower everything. I highly recommend using macros. They're wonderful. And you're going to end up using regex, even if you don't want to. It's just a fact of life. So here you can see I have some macros. Where are they? No, I don't have them yet. You'll see them in a second. But we do trimming, we do parsing, and we do lowering, all that fun stuff to make it easier to match things down the line, because having lower cases and having no spaces obviously just makes it easier to figure out if two things are the same. We also do macros. I probably don't have to convince anyone on this call that they're great, but I'm going to tell you they're great anyway, because look, we can do things like separate an email into the user and domain. Imagine writing this more than once. Nobody wants to do that. You can remove stop words, and as you find new ones, you just enter them in one place. There's actually mistakes in this regex, which I just realized. 2 slashes, not 1. That'll trip you up. You can pick domains you don't want because they're not really domains for a website. For a startup, I don't think Facebook is coming to Vouch for insurance. And you might want to use things if they have nulls and NAs to a null value. So macros, they're great. Use them. You won't regret it. Regular expressions, I'm sure you've seen this quote. If you start using them, you're going to have problems, as you saw in this slide where I forgot the slashes. But if you use DBT call statements, somehow all your problems go away. And if you're wondering what a DBT call statement is, I didn't know until I knew I had a problem that it would solve. And essentially what I wanted to do is say, I have this file of regex things, patterns, if you want to call them patterns, that I want to remove from our applications, because these are test accounts, these are people internally, they're just clutter, let's get rid of them. What I don't want to do is write this statement and then have to add to it every time I find someone being bad. What I really want to do is maybe have a CSV where people can just upload it, and then that'll propagate through everything. So we do this little call statement. What it does is it goes to the database, it fetches this data, and it sticks it in here. I'm pointing with my hands, but you can't see them. It takes it from here, and it sticks it in here using this little loop over here, and I think over here it reads from the database. How does it work exactly? I don't really know. You just ask in Slack, and somebody has already solved this problem for you, and then they'll give you the answer. And that's what I do. And so we got a bunch of macros like get email parts, we talked about, clean company name, trim lower null, and obviously it gives you this long thing. You can see immediately why macros are great, because you'll never have to fix this more than once, only once. And then you get basically, yeah, here. So we've done, what have we done so far? We've got in our applications, we've got maybe data from different companies. We did our filtering using the magical call statements. And then we've created our staging tables. The staging tables are the ones that are useful everywhere, right? So we're going to filter out junk applications everywhere because nobody cares about them. But to do the prep, that's a different table, because you don't want to lowercase and remove stop words on company names for everybody. You just want to do that for your own internal modeling. So for each source, we get a little prepped table, and then we get ready to score them. And this is where the company's scored table comes in. And I'll show you what that looks like now. So here's what we did on the right so far. We cleaned the names. That's pretty straightforward. We cleaned the websites. That's kind of nice. We got the email users. And we even included where this particular row came from as an object, just so we can refer back to it when we find problems. One other thing we've done is create a thing called a blocking key. Now, this is stuff that I was not familiar with when I started down this path, but a blocking key is essentially just a way to reduce the information in names and websites to something smaller. And why would we want to do that? I'm glad you asked. Let me do a pop quiz. You have 2 databases, one with 100,000 records and one with 10,000 records. And you want to check if the company name and website are similar. How many comparisons do you end up doing? I'll wait for you to Google algorithms, but if you forget, don't worry, I have answers for you. Same question, well, kind of same question, but you're just checking for duplicates instead in one database, 100,000 records. And all you want to do is check to see if the company name and website are similar, 2 comparisons. How many comparisons do you do? If I did the math right, it's like 2 billion for the first one and 10 billion for the second one. Is essentially you're checking every single record against every single other record times the number of predictors. In the deduping case, you divide that by 2, and then you get too many comparisons. No one wants to do all these comparisons. So you check back in 12 days, hope your script runs, and it's not going to because you ran out of memory. Indexing fixes that problem. And what it says is like, we probably don't need to check DBT against Fishtown Analytics to see if these are the same record. They're probably not. But how do we sort of put the things that are similar same-ish, close together, put the things that are different-ish close together, but separately. And the answer is these blocking keys. There's many ways to do blocking keys. You could do only by zip code. You could do by last name. You could do by other methods that are in that book. What I'm using is very simple. It's called SoundX. It's in Snowflake. It's a nice function. It takes any string and it reduces it to these 4 characters. First letter is based on what the sound is, and then these are what other parts of the sound are like. So things like whoops, fishtown and fishtown, the PH get the same SoundX. Isn't that great? And things like Vouch.com, Vouch.us get almost the same one, but they don't. So it's not perfect, but it's close enough to be good enough for our case. I think like 95% of the time it sort of matches things based on me doing some checks. So it's good enough. And then what we can do from there is only look within the box. And that reduces your search space from this much to that much, which is great because then you can actually solve this problem. And so now we get into Python because the rest it's more complicated. Any questions yet? I can't see the chat. And I can't.
We're all just marveling at SoundX.
Yeah, SoundX is great.
We're like, what? Like, I've never heard.
It's amazing. It's amazing. Yeah. Like, I can't get enough of SoundX. It's just so good. Yeah. It solves all your problems. Reverse indexing is the next step. So you're really smart. You read this book. You've created your blocking keys. And now you got to sort of reverse the flow. You got to say, okay, which records have D130 as a blocking key? And we can see these records 1 and 2. And it's amazing. It's like I picked examples that work really well. So obviously, every single match has the same blocking key. This happens in real life too. And then you're almost done, right? You're like, okay, well, 1 and 2 are the same. 3 and 4 are the same. 1 and 7 are actually not the same, but we'll compare them and make sure that that's not the case. And then you got 2 by itself, you got 5 and 6, and you got 7. So you got sort of these like candidate pairs. I'm going to check these 2 and check these 2 and these 2 and these 2 and all and so on. I'm going to check them all. In real life, it's going to be lots in a single block, maybe thousands, but thousands is better than hundreds of thousands or millions. So now that you know what to compare, you're like, okay, let's just check them out. What's what, right? And how do you check things? Quality is the easiest. Like if the strings are exactly the same for the name and the website, then they're probably the same company. You can do string comparisons like Levenshtein distance, everyone's favorite. That gives you a score, maybe between 0 and 1. You can do numeric comparisons. I have a slide here on some examples. You can do things like, are the number of employees close enough? Are they within 25% between these 2 sources? You can do dates, ages, times. Like, are they both created around the same time? Or both companies incepted at the same time? Are they in the same geographic area? You could do lat longs. You could do states. You could compare. And this is all going to depend on your particular use case and, domain-specific knowledge, which is the most important thing out of everything in here, right? And so in our case, I'm really just looking at name and website. There's more in there that I could probably do, but iteration 1, name and website, got me 95% of the way there. But there's definitely more ways you could sort of score things. And so once you've compared these records, you'll get a score. You might get an average. 0 to 1 is great. 0 to 100, also great. Just a bunch of numbers, right? Oh yeah, LRU cache is something I learned about recently in Python. If you got a function that you're going to run a whole bunch of times, and a lot of the inputs might be the same, if you use this decorator from the func_tools package, it'll cache the results. And because this is actually a non-trivial statement, it takes a little bit of time, especially if you're doing it hundreds of thousands of times. So if you cache it, it makes it faster. I think about like 25 to 50% faster when I ran this. So nice trick. And then let's say you did your comparisons and you said, okay, here are my true matches, like 1 and 2, true match, 3 and 4, true match, true match, true match, this one all by itself, and then these 2. Another pop quiz, how do you make this into that? Well, what you do is you ask your friends on Slack and you tell them your problem and you pretend it's a quiz. And then your friend M here says, oh, intersection of sets, sorry, wrong answer, but good try. Friend F calls you out and realizes that you're not quizzing them, but you're trying to source information. And then you tell them, well, Google search history has not been very helpful. It's really hard to think of how do you phrase this problem? Eventually you get a Stack Overflow and it starts to click. You're like, oh yeah, graph theory, everyone's favorite. These are actually links in a graph and you want to find some sort of way to connect them, connect the components of a graph. Now you start Googling. There's a Python package for it. Oh, thank you. So you import from network X and you make a graph and then you can create your components. And that basically generates this. Great. So now you know that you have two entities really, right? One is made of five things and one is made of two sources. You think you're done, but you're not. You actually have the hardest problem now. And that's to decide on what values to keep for everything. Let's keep it simple. Let's say we just have name and website, and you have maybe 3 competing names in the first example. What name do you use? What website do you use? As a data scientist, you're probably going to say, oh, just keep them all and put in an array. That way you don't lose any information. And then the business people will say, how do I understand an array as a name? That's not going to work. I need like a company name for something. I need a website. I don't need an array of strings for a name. I can't work with that. So then you have to decide, all right, okay, what do I do? Well, you can just pick one at random, which is perfectly fine. You could rank your sources, probably better. You could do the union set. No one's going to like you, but you can do that. You can do a range on numbers, which is sometimes helpful. And there are many other ways to sort of merge your data. Check the book. They're all in there. So if you're picking one at random, you're just saying, all right, whatever, just give me one. I don't care. And that could be fine for certain fields. Ranked is preferred. The way we do it is if the data comes from our own internal database, that's the name we use. If it doesn't come from that, we pick in order what I think are the best sources for names and websites, just based on looking at things. That's usually good enough. A union set can be nice in certain cases when you need to do more work with the data. So one weird thing about merging data is that if you had record A and record B, and they match, but they don't match with record C, what could happen is if you merge record A and B, they now match with record C, which is like a weird equality statement. And the way that would work best is if you had a union set of all the elements in those records. There could be something in A and something in B, and then when you combine them together, they make this powerful thing that can now merge with C, and now A, B, and C match. That's where union set is kind of helpful. It's also helpful in things like collecting the sources. So where did this entity come from? What are the source systems and IDs? That's a great place for a union set. And then range is great for things like, oh, how many employees do they have? 10 to 50, 23, something in there. Put a range and then it's probably fine. How much funding did they raise? Between 5 and 10 million? Okay, that's fine too. You could pick a lower bound, you could pick an upper bound, you could pick the median, the average, all kinds of fun stuff. Lots of ways to merge. And then when you're done merging, you think you're done, but you're not quite there yet. You still have one last step, and that is to, well, okay, we got this step, right? We decided to do union set because we're lazy data scientists who don't like making decisions. And so we've got names and websites and sources and employees. The only thing missing is to bring it back into DBT. So we were in Python, we made a nice table. It looks like this. We upload that into DBT. And then we continue down the pipeline, create a view, maybe we create some more views, and then eventually this comes into our systems, like our application system. And if you're very observant, you might notice that there's actually a circular dependency because this was a source, the applications was the source for company information, and now it's coming in through here. But because it's in Python, DBT doesn't know, and it's not technically broken. So I actually could not do this entire pipeline in DBT because the data feeds right back into the source. Yeah, so then you got the data, you've got your names, you got your websites, you got your sources. The only thing missing is an ID, and those are easy to make. You just make one up. Start from one and you go all the way down. That's the make one up randomly approach. Perfectly fine, but not great. I prefer a deterministic approach, which uses the inputs from those values. So you can see I take, whoa, what happened? We have company names, we got websites, and I use an MD5 of those. If we have both those things, they're probably unique. These are union sets, so they're very likely to be unique if my deduplicating logic worked. If websites are empty for whatever reason, then we might take names and sources because multiple entities could have the same company name, but they could be separate. And you make a hash out of that. And no one likes reading 32-bit hex strings, so add some dashes, and then it looks like a real ID, and you're done. And then you just have to remember that what you created has certain guarantees and doesn't have other guarantees, so make sure you communicate that. What you have done is you created a unique ID for a particular entity that you have deduped, not deduced. But if anything about that company changes, like the names, the websites, the sources, you might change an ID. So it's not persistent through time, but it's deterministic, which is nice. You can always get to an underlying source for a particular vouch ID too. So because we include the sources in here, you can say, all right, I know all the things that made up this particular ID. So at least you have that guarantee. You can always dedupe, but you don't have a persistent ID throughout all of time, which is a very different thing and a much harder problem to solve. And then you're done, I guess, right? Yeah, you have your IDs, you have your companies, everyone's happy, and then you learn some lessons, as you always do. My lessons are never technical, they're always philosophical. So start small. Don't try to dedupe your entire database. Don't use all 3 sources. Do a limit of like 5,000 rows and learn how that works. And then just accept that you're going to fail at it. You're going to fail when you try to build it. You're going to fail when you try to read the book. You're going to fail when you try to implement it and you run out of memory. You're going to fail when you deploy it and people complain. You're going to fail when you communicate and then they don't really understand what you're saying. It's going to happen, but just accept it and move on. And then just make sure you communicate what you built and what you haven't, because you're building a problem that might solve like deduplication across records. Your business stakeholders are going to want something way more complicated and way more useful to them. They're going to want a record persistent through time that takes into account when companies merge and separate and get acquired. That's not what you build. So make sure you emphasize many times that that's not what you're building. You just help them dedupe records in the cases where we were able to find out that they were the same. It could be we've missed them. It happens. It's not perfect. It's just a helpful tool. Yeah, and that's it. I'd be remiss if you didn't say we're hiring. I don't have another slide. Oh, yeah, I do. Oh, there we go. We're hiring. That's me. That's my email. That's the website. Feel free to contact me if you want any on the application process. We're hiring a software engineer to work on my team. So if this process sounds cool, if these problems sound cool, please help me fix them. And that's all I got.
Incredible. I'm going to kick us off with a question. I can also see that Dennis has got a question, so I'll let Dennis chime in straight after me. But if anyone else on the call has a question, feel free to just pop it in the chat so we can throw to you. So, I'll also introduce myself again in case someone joined late. And if you are asking a question, take a moment to introduce yourself. So I'm Claire, was in those slides as Claire at Fishtown Analytics. I'm curious how, this is a question I ask a lot of these kinds of things. Like, is this a project you would recommend for small teams, for big teams? Like, where do you see sort of the inflection point where it's worth, like, as a team going, yeah, this is something we want to invest in? Because I'm sure, like, there was a lot of, like, investment in this project in terms of your time. And yeah, I'm curious about whether you have any, like, good heuristics for when to take on this project or when to say, you know what, not a project we're going to solve right now.
It's a great question. When I was interviewed, they asked me about this problem, so I assumed this is top of their mind. And so I think that would be a good sign that they probably are hiring you to solve this problem if they're asking you about how you would solve it during the interview process. More generally, I would say you can do it as a small team. I did this mostly alone, but I had time because it was like the first month that I joined, and you don't have a lot of other work happening when you first start. So I had the space and the time to do it. Could I do this right now with everything else going on in my life? Yeah, but it would take a lot longer. That's a conversation between you and your business partners. It does deliver a lot of value, right? It helps in funnel. It helps in reporting. It helps with communicating to your stakeholders. We work with third-party insurers, and they want to know, how many applications are turning into policies, and that's an important question to them. So for them, this is a real problem. It also depends on your data. Maybe you don't get that many duplicates, so maybe not an issue. We're also connecting our data with third-party data, and there's no other way to do it but to link records. There's no single identifier. If there was, my job would be simple, but it's sort of a pressing need, and if they really need it, like, then you won't have a choice but to implement it, I think.
Yeah. Cool. I'm going to read out Dennis's question. I think he had to jump to a 12:30 meeting. I should have let him go ahead of me, but I just realized that. So Dennis Hume from Drizzly wants to know, he said he's going to watch the recording later to get the answer. So what do you use for orchestration and bringing the dbt and Python processes together? How often are you running these processes?
Great question. I use our best friend Airflow to do that. Airflow runs the company deduping script once a day in the middle of the night. So we do that, and then any applications that happen after that don't have a vouch ID right away. So that's something we do communicate to our users. Like, it could be blank, so just be aware of that. But within 24 to 48 hours, you'll have a vouch ID for that record. And then dbt runs every 4 hours right now for us, just to refresh tables and all that.
Very cool. Michael, are you able to ask your question?
Yeah. So my question was kind of on the last communication point you had mentioned, which is basically once you have everything like solved technically, how do you get it kind of flowing back into the business side of things, get other people and teams like invested in using these IDs and like understanding what they are? How do you make sure it doesn't just become like one more ID other people have to kind of manually match up to things?
It's a good question. Right now, we have so many IDs. We have the application ID, which is unique for an application. We had an attempt previous to when I joined called a company ID, which was unique to a company sometimes, depending on a whole bunch of like scenarios, but typically not unique. And then now we have Vouch ID, which proposes to solve everyone's problems. I found that I have to stop people from using it rather than convince them to use it, which is a good problem to have. I put it in the tables because it's the first row, it's the first column you see in our applications table and our policies table. It's Vouch ID. And everybody wants to dedupe, everyone wants to join things together. So they started using it almost too early, which has been my problem because it hadn't been really vetted yet. It's really hard to know if this is working well, right? It's hard to know if the number that goes down has gone down the appropriate amount. And so part of what I was trying to get our stakeholders to do is like test it, not use it. Typically they don't want to test things, they want to use it. And then you'll get the testing in the field when you make a mistake. That's what I found. A great one is a company called LLC LLC. Doesn't get a vouch ID because it doesn't have a name because I strip out LLCs from company names. Turns out as a test account, so it could filter out anyway, but stuff like that will creep up for sure.
That is, I was hoping it was a real company and I was like, that is an awful company name. I'm glad it was a test account. Cool. We've got a couple questions from Sterling.
Sure. I've been thinking about this at a very similar problem in my company, and I stumbled across the dedupe.io Python library. I was wondering if you knew about that one as well, if you evaluated against your own
I did. I looked at dedupe. There's also one called record linkage. Did I freeze? No. Okay. Sterling froze, I think, right?
Sorry, I was muted then. I think you're good. I think Sterling froze, but his second question's in the chat, so I can read it out if needed.
Sure. So first question, yeah. Record linkage, dedupe.io.
I ask a question, then it
Well, we've got the recording, so we can always
Probably
send it back.
me.
Yeah, Sterling, I think it's on your side.
So just to quickly answer the question, yes, I looked at them. I looked at them mostly for their source code to figure out how they're doing things. But for me, it was actually a lot simpler to implement it in Python, just using simple data structures than to use their not so well documented API.
I'll read out Sterling's second question just in case there's problems again. So when your business users really, really, really want two records to be merged together, but they don't get matched using the algorithm, how do you handle that? Or do you just communicate that it's not possible?
That's a very good question. It's something I'm still trying to figure out. The answer right now to them is, please wait. Let us know, but please wait. We haven't solved everything. This is just round one. I'm thinking about ways of like forcing things to match using a separate table that we create and then doing joins there. Things get complicated very quickly when you try to force things to happen. And then you have to think about all kinds of other scenarios I don't like thinking about, like company names change and websites change. How do we know that they're still the same thing in our systems? Or companies merge, companies break up into new things, companies create sub-entities. Do you still want those force matches? I don't know the answer to that. I guess that's my
Maybe
answer.
a follow-up office hours if you make some more progress on this. That'd be cool. Aiden, are you able to ask your question?
Yeah, for sure. So my question's mostly around kind of bridging from the comparison step to the classification step, and sort of two questions nestled in here. First of all, how do you go about ranking the various methods of comparison that you might have? So like we're going to place more weight on the latitude, longitude than on fuzzy text, for example.
Yeah.
And then once you've compared using all the comparison methods at your disposal, how do you go about determining that like a comparison is kind of good enough to say that these two are indeed likely the same?
You caught me. I skipped over the actual hardest problem because there's not a great answer. What we do internally is a decision tree with like 2 or 3 steps of, is the name and website close enough based on me looking at a couple thousand records and glancing at them and thinking, okay, this is good enough for us. There are supervised methods if you want to go that route. What the problem with those is that they require you to know the truth first, which is really hard to do. And if you knew the truth, you wouldn't have this problem. There are cases where you might be able to fake the truth by saying, okay, if the name and websites are the same, let's just pretend that these are the same. And then if they're vastly different, let's call those bad examples, build a classifier. But essentially, you've trained your classifier to just be a decision tree anyway. So there are more complicated methods. My recommendation is to just like use your instinct and your gut on what you think is most important based on your understanding of your use case. That will beat any classifier in this world right now.
Thank you.
My other tip there, having done like a similar project before, is to ask your customer support people. You'll be amazed when you like go to a customer support rep and you say, if you have the admin panel open, how do you know if these 2 people are the same 2 people? And they'll have like a wild list of ways that they know these things. So they can also be really useful because they have to do it manually all the time. And we're just trying to like automate that manual process.
Exactly.
Okay. That's all the questions we had in the chat. If anyone wants to quickly jump in with another question, definitely feel free to. As maybe someone from my team fill in a question really quickly. No, I put everyone under pressure. But generally speaking, this was really incredible. I think it is a thing that isn't, a question that we often get from stakeholders where it's like, isn't this an easy thing to do? Like, isn't this why can't we just have that, like a single customer ID, a single company ID? And it's like, oh, no, this is actually a very hard problem. So I'm glad we had this talk today because I think it's, there is no perfect solution, and it is about like, how do we sort of improve our knowledge as a collective to figure out how we can solve this problem better, and apply it to each of our use cases.